All right, today we're going to talk about classifying and comparing polygons. Okay, so classifying and comparing polygons. You need to go ahead and add this to your quarter 2 table of contents. The objective is 5G3. Okay, 5G3. Alright, and the first thing we're going to look at together is kind of what kind of words or vocabulary can we use when we're trying to talk about a comparison of polygons. Okay, remember the word polygon simply means a closed figure with 3 or more straight sides. So the biggest points for a polygon, it has to be closed, 3 or more sides, and the sides have to be straight. Okay? So that would mean a triangle is also a polygon. So what fits under the polygon category? Well, a triangle does. If we think about a triangle, does it meet these 3 stipulations? Is it closed? Yes, it doesn't have any openings. Does it have 3 or more sides? Yes, it has 3 sides. And are the sides straight? Yes, so that means a triangle is also called a polygon. It's a type of polygon. Okay? A triangle is a type of polygon. All right? So anything, when we talk about squares, we talk about rectangles, we talk about parallelograms, we talk about quadrilaterals, we talk about octagons, hexagons, we talk about any of those kind of shapes. When we talk about equilateral or scalene or isosceles triangles, these are all types of polygons because they fit all 3 of these categories. They're closed shapes, they have 3 or more sides, and their sides are straight. Okay, so a triangle is also called a polygon, or it's a type of polygon, and there are many other shapes that are types of polygons. Okay, so we're going to look at this page from day 44. And we're going to look at the corresponding pages that have the different shapes on them. Okay? Look at the corresponding pages that have the different shapes on them. And the first thing it wants us to find is an acute triangle. I know acute means it has angles less than 90 degrees. And a triangle has 3 sides. So I'm looking for a triangle that has angles that are less than 90 degrees. Okay? So I'm looking, I see a triangle here at shape A, okay? I see a triangle shape D. I see a triangle for shape I, shape L. Let's see if I see another, I think that's our only page of shapes here. So one of these 4 shapes, A, D, I, or L, is an acute triangle, which means it has angles less than 90 degrees. How do I measure an angle that's 90 degrees? Well, if I take the corner of a sheet of paper, this is exactly 90 degrees. Okay, any sheet of paper will do. If I put it in the corner of my angle, and that corner fits perfectly, then that's a 90-degree angle. Remember, acute is less than 90 degrees. So this, if it's exactly 90 degrees, then that means D is not my acute triangle. Okay, if I put it into shape I, notice one of the sides of my paper has to line up with one of the sides of the triangle. This goes out further than 90 degrees. Okay, so that means it's not less than, but it's bigger. This would be an obtuse triangle because it goes out further than 90 degrees. If I put my paper, corner of my paper here, this one also goes out further than 90 degrees. So that means it's obtuse because it's more than 90 degrees. If I put the corner of my paper here on shape A, I see that this is under my paper, which means it's less than 90 degrees. The line is actually right here, and 90 degrees means it would have to extend out further. So that means that shape A is acute because it's smaller. Its angle is smaller than this corner of the paper, smaller than 90 degrees. Okay, so I would write shape A here, and I could say the definition of an acute triangle is a triangle with an angle less than 90 degrees. All right. If we look for, let's look for a parallelogram, because we haven't even talked about a parallelogram, but we're going to briefly talk about that now. I see parallel in here in my title of my shape, and I know parallel means that it runs in the same lines that run in the same direction but never touch. Okay. So a parallelogram actually has opposite sides that are parallel. So what does that really mean? Okay, so let's look at our shapes. Let's look at shape, let's see here. Let's look at shape C first. When we look at shape C, okay, when we look at shape C here, we see that this side is opposite, okay, this side right here up top, this side length on top is opposite from the bottom side length. So those two are opposites, okay? And if we were to extend those lines out, we would see that this line on top runs in that direction from left to right. This line on bottom runs from left to right. But if we extended them out forever, they would never, ever, ever touch each other. Now they touch these side lengths, but the opposite ones, the ones opposite on the opposite side of the shape, never touch each other, and they run straight or parallel with one another. Okay, so C is what we could classify as a parallelogram, and we know this is a polygon because a parallelogram, it has those straight sides, it has 3 or more sides, and it's closed, so it can be classified as a polygon that has opposite sides which are parallel, which means those opposite sides, if we were to extend them out, they keep going in the same direction, but they never ever touch. Okay? Parallel means they keep going in the same direction, but they never ever touch, whether that's left and right or whether that would be up and down. And if we look over here at these opposite sides, so this is opposite side number 2, these go in the same direction, but they never ever touch. Okay? So all the opposite sides on this shape go in the same direction and never touch. Okay? And if we look, that's true for shape B as well. You might recognize it as a rectangle, but it's also a parallelogram because the opposite sides, here's the top, here's the bottom, they go extended out, same direction, and never touch. So we could also list shape B. All right, let's look at pentagon. Now I see the prefix penta here, and I know that that prefix means 5. So my guess is that this is going to be a polygon with 5 sides. And if I look, I see that letter F has 1, 2, 3, 4, 5 sides. So letter F would be a pentagon. And it's also a polygon. Remember, we talked about the definition of a polygon. Those 3 things it has to have. It has straight sides. That's one qualification to be a polygon. It has 3 or more. It actually has a total of 5, so that's more than 3, and that's fine. And it's closed. There's no openings on the shape. So it's a polygon that has 5 sides. Okay? Let's look at isosceles trapezoid. That one's tricky. We know isosceles means that it has the same 2 of the same side lengths. So if I look for a trapezoid, I know a trapezoid typically looks like this. okay? And I see that these two are the same, so I'm really looking for a trapezoid that looks like that. And when I look at my page here, I see that I have a trapezoid right here, letter H, and these two sides are congruent, or they are the same, okay? Letter H. Those two sides are congruent or the same. So I'm going to put H right here, and this is a four-sided polygon with two congruent sides. Okay, with two congruent sides. All right, if you look on the back, there's some other shapes listed, like a rectangle, a rhombus, a right trapezoid, a kite, and a square. What I would like for you to do is I'm going to give you a vocabulary list to take home with you. And you are going to use that vocabulary list in these shapes, and you're going to try to finish filling in the blanks here that we have not filled in yet. Okay? Finish filling in the blanks here that we have not filled in yet, and I will check over this, that you've at least tried this activity. I will check over this tomorrow as a completion for your homework, your math video notes for tonight. All right, the silly saying for today is that Aiden's birthday party theme was Caillou. All right, I'll see you guys tomorrow.